1.
Hello, everybody. I'm Nigel Croft, and I'm here with Dr. Shaukat Malik, who's the Chief Technical Advisor for the project, the UNIDO project in Sierra Leone. And today we're going to be talking about understanding the process approach to quality management. Many of you may have heard this many times before, but ISO 9001 in particular specifies a series of requirements that an organization has to meet in order to provide confidence to its customers that it has the ability to provide them with consistent, conforming products and services. Now, ISO 9000 is built up around a series of clauses, but organizations don't work on clauses. You know, typically in your organization, there isn't a department for clause number 6 or department for clause number 8. Your businesses operate around processes. And so your quality management system has to take into consideration and also be built around those processes. So this is the first module of a 2-module element, where we're going to talk about what are the tools that you need to be able to understand about this process approach. So let me pass over to Shaukat, and Shaukat will introduce the project and also introduce the topic of process approach.
Thank you, Nigel. Good day to everybody. Yes, we are going to organize this training course with the support of the UNIDO project that is EU funded, and it is West Africa Competitiveness Project overall, and with respect to Sierra Leone, it is Sierra Leone Competitiveness Project through the EU funded support of 11th EDF for Sierra Leone. The project has basically, next please. The project has basically 3 main pillars. One is the quality infrastructure services, other is the value chain, and the third pillar is enabling the business policies. Quality infrastructure, as you know, is with respect to the testing, certification, and inspection, overall conformity assessment services. And the value chains are basically, for Sierra Leone, we have selected the 3 value chains. Those are cassava, palm oil, and cocoa. We have to improve the value chain productivity and quality by improving the losses. They are from post-harvest up to the storage and then transportation towards final export. And by improving the productivity and quality as well, we would enable these value chain to be exported on the regional as well as towards international level. Next, please. UNIDO has always the 3 C's approach for this competitiveness project to improve the competitiveness of the agriculture produce, then to conform those agriculture produce towards international standards and the regional standards, because once the produce would be certified that these are safe for human consumption, these are of good quality, then you can connect those produce to the regional as well as to the global market. So this is basically 3 C's approach to link the produce to the regional and the international market. Next, please. As Dr. Nigel has briefed you, we are basically going to conduct this training course with the 2 modules. One is the module 1. We will cover these topics in the module 1, and then after that, it will be little bit high level process mapping course. That will be module 2. Next, please. What is the process? Before we move toward the process mapping or the process management, the understanding of the process and the basic concept of the process is mandatory. In this example, as you can see that there is a process map with respect to the value chain, and that is cocoa value chain, starting from the cocoa beans towards the cocoa powder and towards end product is the basically chocolate. And there are many steps in between them. Those are starting from cocoa beans towards fermentation, towards roasting, and then towards shifting it towards the final chocolate. And as per the ISO 9000 2015 definition, process is basically the set of interrelated or interacted activities that use the input to deliver an intended result. I mean, every process has the input, and then there is some value addition on it, and at the end there is some output. So these are the basically we have discussed in ISO 9001 module when we were discussing that the process has every process has some input, and then there is the output. But in between that, you are adding the value, and that is basically the process. For example, here the input is the cocoa beans, and the output is basically cocoa butter or the chocolate in this example that is on the right side of this presentation. But in between that, there are many steps. And those are some of the steps are activities and some of the steps are process. But then what is the difference between activity and the process? In the process, you have to add the value. And activity is just an activity. Here you can say the activity is basically uh, feeded by any input, and then it is shifted towards any output. Activity cannot be further subdivided, while the process, for example, in the turning on the car engine or fill out of the form, measure of the temperature, all these basically are the activities, while the process is, for example, in the turn of the car engine, basically is the start of the car is a process, but when you are turning the car, that is a activity. Next. There are internationally basically are some of the recommended signs with respect to these flow charts when you have to develop the process and the activity. You have to show that what is the input and what is the output, and what are the sequence of different steps and different activities and different processes. So there are some symbols; those are well recognized symbol in the world, and those symbols are here. You can see that the symbol at the top, uh, this is basically the start or the finish symbol. When you have to start any process, you have to start it with this symbol, and then you have to show the activity with the rectangular, and then output is again an arrow. I mean, input is arrow and output is arrow, and in between that, this is an activity. After the activity, when you have to take the decision, for example, you have in the previous example, when you are basically making a coffee, you have to take the decision that when I may put the milk in it, or when I may put the coffee when the water is hot, up to what temperature the water should be hot, and you may put the coffee in it so that it may give the right smell and the right formulation. That is decision. If the temperature is meeting at that point, you will put the coffee in it. And if the temperature is not meeting, you will shift to again the previous activity. And the previous activity is keep on boiling the water. So when you will be sure that now you are getting the right temperature, you will put the coffee in it. And the next step you will follow that coffee will be brewing. Coffee will be coming at the final stage. And this is the connector symbol in which you can connect some of if the page is over, then you can connect it with other processes or with further steps. Now you can see that the this connection was at the previous page. It is showing that this connection is coming from the previous page, and still you are moving towards another process, toward the continuity of the same process. And these are the symbols. Basically, here you can see this is a documentation symbol, this is the activity symbol, and this is basically I briefed you in the beginning. This is the symbol of the start, or this is a symbol of the end of any process. But if you want to shift or connect to another page, then I mean, some of the processes are horizontal and some of the processes are vertical, and some of the processes are both. They are towards horizontal for some of the processes and towards vertical as well. If you have to shift to the I mean, on a page that is uh, towards other side, then you have to connect with this. Next, please. This is a good software and simple software. This is a Microsoft software, and maybe it is available into the, when you install the MS Office, this is freely available with that package. And in this Microsoft Visual software, there are all these process mapping you can draw. This is a visual software, image of the visual software. And here you can see they have given many symbols and many process flow diagrams. So if you will go to open a new file, they will show you different options. And then as per those options, you can select any symbol, and you can simply, you have to click it and you have to place it on the file that you have opened, because this file contains some pages. And then you can keep on adding the pages further, and from here you can basically, you can see that the symbol that we were showing you in the previous slide, these are the connectors and other things. You can place those symbols on this page and you can keep on continue. So this is a good software and almost free software. There are many other softwares, but this is a almost included into the world MS Office package. That is why you can put it, drag and drop are here option, and you can draw your process flow diagram. Thank
Okay,
you.
thanks, Shaukat. I think what Shaukat and I agreed was that we would split this presentation. So I'm now going to take those basic ideas and let's try to transform this into something that we can all probably associate with. As you know, the British are great tea drinkers. I'm not sure, I think Sierra Leone likes coffee, but we like tea. So we're going to use as an example a tea shop. So when we're thinking about the process for that tea shop, we need to relate that back always to a set of key questions. You know, what are the requirements for that process? So we may ask, who are the customers? Who are the customers of that tea shop? What do they want? What do they explicitly want? Well, of course, they want a cup of tea and maybe a sandwich or some cake to go with it. But what are their implicit requirements in terms of speed, in terms of courtesy, in terms of comfort? Now, those requirements may be different depending on the kind of tea shop or coffee shop that we're dealing with. If somebody just wants a very quick cup of coffee or cup of tea on their way to work, then of course, some of the key requirements for that cup of tea or coffee will be speed. They're not worried about having a very pleasant ambience and being able to sit around and talk to their friends. They want the cup of tea or coffee served quickly, probably served in a polystyrene cup to keep the coffee hot. They're not interested in fine china tea services and waiters with, you know, posh uniforms serving them the tea on a silver tray. So all of these things are inputs into the way that we would develop that process for serving tea in a tea shop. What are the statutory and regulatory requirements? Are there any health and safety requirements or other requirements? Things like, do we need, if we have a sit-down tea shop, do we need to take into consideration fire evacuation routes? Do we need to have fire extinguishers on hand in case the kettle catches fire? All of those kind of things. And what are the actual tea shop's requirements? What are our requirements in order for us as a business to operate effectively, efficiently, and hopefully profitably? So these are all factors that come into play when we are thinking about defining our process. So as I say, a tea shop, it could be a fast food place, or it could be a high society meeting place where speed of service is actually the opposite. People don't want a quick cup of tea thrown at them and here's your tea, now here's your bill, and now get out. They want to be, appreciated. They want to maybe spend 2 hours over, informal, friendly discussions with friends and colleagues. In things like coffee shops, needs and expectations change over time. So many people now go to a coffee shop. Yes, they want a cup of coffee, but what they really want is a good internet connection, a good Wi-Fi connection that they can use while they are in the coffee shop. And some people spend quite a long period of time and they make their coffee spin out so they can use the internet connection. Or they may use the coffee shop as a meeting place with business associates. So what we need to think about always is what are the characteristics of the particular business that we are dealing with? What are the characteristics that will affect the way that we design our processes? And we've spoken in the other course earlier about ISO 9000 and some of the definitions. So if we think and relate this to the tea making process, then some examples of characteristics. The physical characteristics. Is the tea cup, is it supportive of the tea? Or is it just going to, if we're using plastic or cardboard cups, is that just going to disintegrate before we have a chance to drink the tea? What about the sensory? Does the tea taste good? Does it smell good? The behavior of the people who are serving the tea. The ergonomic effects. In other words, if we are sitting down for a cup of tea, is it a comfortable chair that we're sitting on? And functional, such as the size of the cup of tea, whether it's hot or not. So these are things that we need to think about when we are defining a process. Now, as part of all that overall process, there will be specific operations involved in making the tea. So what I want you to think about is, in a tea shop, there are actually a number of interrelated processes. If we take the example of a tea shop that is serving tea, let's say tea and cakes in a hotel, there is a process for receiving the guests. Somebody comes along to the tea shop or the coffee shop in the hotel. They don't want to just have to stand around waiting until somebody comes and greets them. So there has to be a sub-process for greeting the guests and then taking them to the table and giving them the menu to choose from. And part of that very important process is the process of actually making the tea itself. So that is where I'm going to focus, but we have to recognize that this is just part of the overall infrastructure for making tea. It's a very, very simple example, but I think it will help you to understand the interrelationships between the different processes that are involved. So when we think about making the tea, what are the inputs into the process? Well, one of the inputs may be, what kind of tea does the customer want? You know, I was brought up in Yorkshire in England, and until I was about 18 and went to university, I thought tea was tea. There's only one kind of tea. In England, you know, my mother would say, would you like a cup of tea? And I'd say, yes, please. And that was it. It was, you know, maybe a blended tea by one of the brands like Thai food tea or PG Tips or all of these things. But it was essentially black tea. And I went to university and a whole new world was opened up to me. Somebody said, would you like a cup of tea? And I said, yes, please. They said, what would you like? Would you like Ceylon tea? Or would you like some Lapsang Souchong? Or would you like some Earl Grey tea? And I didn't have a clue what they were talking about. Would you like it with lemon, or would you like it with milk? Or would you just like it with nothing? So all of these are aimed at defining what is the output that we want from that process. And then we need to think about the inputs. What resources do we need? Well, of course, we need hot water. So we need to have a kettle or something else to boil the water. Do we actually need to measure the temperature of the water? I would say no, we don't, because we can observe it. We don't need to measure it, we can monitor it. When we see it starting to boil, then we know the water is ready to make the tea. We need a cup, or, you know, in my case, a nice big mug to drink the tea from. We need possibly sugar or sweetener and milk and all of those things. So all of these are the kind of information that we need to be able to make a cup of tea that will meet the needs and expectations of our specific customer. So if we start very, very simply, if somebody says to me, Nigel, how do I make a cup of tea? I say, well, you boil some water, you make the tea, you know, you may either use a teapot or you put these days we tend to put a tea bag in a mug, you pour the hot water into the cup, and that's it. Well, as a macro view, maybe that does give us an overview, but it's obviously a little bit more complex than that. A macro view is very, very useful for people to understand how the different steps fit together. If you're actually going to do that process, then the amount of detail will depend on the competence and the knowledge and the skills of who is actually going to be making the tea. So if we then look a little bit more detail, how to make a cup of tea properly, maybe the start of the process up here, we fill the kettle with water. We heat the kettle until the water boils. In parallel, we will have chosen what kind of tea we want to make, and we will have put some tea in the pot. It may be in tea bags or it may be loose tea. We then fill the teapot with boiling water. Now, there may be a step in between here because for me, one of the secrets of making good tea is to make sure that the pot is hot before you actually start infusing the tea. So I will typically, in between these two steps, I will typically put in a little bit of boiling water into the teapot, swirl it around and throw it out so that the teapot is hot before I actually start to infuse the tea. I then need to allow some time for the tea to infuse or brew or mash, as we say in my part of England. Yeah? And then we monitor and we look, is the tea strong enough? If it's not strong enough, we need to allow a little bit more time for the tea to infuse some more. If it is strong enough, we pour the tea into the cup and it ends there. Or maybe it doesn't end there. You know, maybe we need to ask, would you like milk? Would you like sugar? Or would you like lemon? And all of these kind of things. So we can build up a process map that is as detailed as we need it to be to allow us to conduct the process in an appropriate way. We can then go more detailed still and look at potential interactions with other processes. So here we would start up at the top again, determine customer requirements, choose the kind of tea, put the tea in the pot. We may have a link to other processes. So when we choose the kind of tea, we may ask ourselves the question, is the stock okay? Have we got enough? If the answer is yes, then that's fine. If the answer is no, in a domestic situation, we would say, oh, we need more tea. Let's put that on the shopping list for the next time I go to the shop or the supermarket. And that provides an output into the purchasing process, which, as I say, it may be as simple as just next time we go to the supermarket, buy some more tea. So we put it on the shopping list, or in a business environment, it may mean opening up a purchase requisition to the appropriate people according to a particular process, or filling out a particular form to be able to do that. And then we start the other part of the process, fill the kettle with water. And we can add comments to that, little checklist. Make sure the kettle and water is clean. Heat the kettle until the water boils. Put the tea in the pot. How much tea? How much tea do we put in the pot? Is it loose tea or is it tea bags? Typically, the rule of thumb is 1 tea bag per person. And so, or X number of spoons of loose tea per cup. We then fill the pot with boiling water and we check that the water is actually boiling, that the pot's clean and not cracked before we start the pouring. We can allow time for the tea to infuse, and we may want to make some notes here, 2 to 5 minutes, depending on the strength required. Is the tea strong enough? Pour a small amount out to check. Pour the tea into the cup, check the cup is clean and not cracked before pouring, and end the process there. Don't forget to check customer satisfaction. So what we're starting to build up here is a process, but with a number of, we'll call these work instructions or comments, that allow people to be able to follow the process and conduct the process effectively. Now, the amount of detail over here, of course, will be impacted by the level of competence and the level of experience of the person who is making the cup of tea. You know, my wife is Brazilian, and Brazilians are not big tea drinkers. They drink a lot of coffee. And so when my mother-in-law comes to visit us, she is not really very accustomed to drinking tea. So I can't just say to her, please will you make me a cup of tea? I will have to explain to her, you know, the intricacies of making a cup of tea, the things that she needs to do, and the good practices. Things like, you know, heating the teapot beforehand. That's key in my experience to making a nice cup of tea. Whereas if I ask my mother, you know, English, been making tea all of her, you know, most of her 90 years of existence, I just say, Mum, please will you make me a cup of tea? She knows what kind of tea I like. She knows how much milk I like. She knows how much sugar to put in there. And she brings me with a cup of tea, and I don't need to give her any additional instructions. So this is what we mean when we talk about process-based approach to quality, not just the manufacturing process, which is the example that we're giving here, but also the process for, it may be an internal audit process, or it may be a management review process, or it may be a process for defining and deploying strategy throughout the organization. All of those we can break down into process flow charts with as little or as much detail as we need to ensure that we are able to carry out that process effectively. Now, the second element of the process approach, and this is all mentioned in the introductory sections of ISO 9001, is to recognize that we can manage processes using the plan, do, check, act cycle. And we talked about this in the ISO 9001 module, but I'd also like to reinforce it a little bit here. Key to all of this is understanding cause and effect relationships. This is an old slide. This is probably 30 years old that I've been using, and you can tell from the little clip art on the PowerPoint that it's an old slide. But the point here is, here we have a magician pulling a white rabbit out of the hat, and everybody applauds and they think it's great. Well, that trick doesn't just happen by coincidence. The magician has spent a long time learning how to perform that trick. He knows what equipment he needs. The top hat, possibly with a false bottom in it or something. A little cute, cuddly rabbit who's able to curl up and hide in the bottom of the hat. There's the method to the way he does it, maybe by distracting the audience's attention while he opens a trapdoor and pulls the rabbit out or whatever. So the point is that the result doesn't just happen by chance. It needs a process, and that process is built up around methods, materials, manpower, measurements, and so on, that allow us to have confidence ahead of time that when the magician sticks his hand in the hat, he will actually be able to pull out a fluffy white rabbit. And so this relationship between process and product is vitally important. Now, the simplest form of a process will have inputs, and we talked about those earlier. Those inputs include resources. They feed into the process, which, as we know, is a set of interrelated or interacting activities. Those individual actions that in conjunction allow us to transform those inputs into outputs, which is the results of the process, which is a product or a service, and that may then be delivered to our customer, whether it's an internal customer or an external customer. We may have a procedure which ISO 9000 defines as a specified way to carry out an activity or a process. It may or may not need to be documented. It may be fully automated. So we press a button and the software does the whole of the rest of the process for us. We don't need a documented process to say, press the red button and wait until things stop. That would be just over bureaucratizing the process. But we need to understand how to carry out that process. In a small and medium enterprise, it may come from just word of mouth. Somebody with a micro enterprise, maybe an owner of a shop who has 3 or 4 shop assistants helping. When those shop assistants first join the company, the shop owner will tell them this is how to do this, and watch them and make sure that they are competent and make sure that they can carry out that particular process consistently without the need for pages and pages of documented procedures. Those pages and pages of documented procedures may be relevant for a complex engineering company or an airline, an emergency evacuation process, for example, on a ship or an aeroplane. But on the other hand, we don't want pages and pages of detailed instructions on the emergency evacuation process for an airplane, because we're not going to go and go through the pages. Oh, on page 16, subclause 7.2.1, it says we have to open the emergency exit. We want that to be very, very pragmatic, very, very instilled into everybody, and the process instructions need to be extremely simple. And then we have the monitoring and measurement opportunities before, during, and after the process. And we've talked about this before, of course. ISO 9001 focuses on the effectiveness of the process. Effectiveness means, is it achieving the desired results? So are we in fact producing a product or service that is meeting the needs and expectations of our customers? ISO 9004, the guideline standard for sustained success of an organization, says, well, wait a minute, just having an effective process is not enough. That process, if we are going to be a successful organization, has to be also efficient. We have to do as much as possible with as few resources as possible. That's the definition of efficiency. It's results achieved versus the resources used. Otherwise, we may be very effective in producing a good product or service, but we are losing money when we do that. And therefore, one year from now, you may be bankrupt. And so ISO 9001, it's important to recognize ISO 9001 focuses on the interests of the customers. ISO 9004 focuses on your interests as an organization. Now, of course, ISO 9001, if you implement it properly, by implementing it, it will give you the process insights that will form the foundations for you to also look at making those processes efficient, driving out waste. That's the essence of what we call Lean Six Sigma, which is also based on a process approach. So here are some ISO 9000 terms regarding processes. In a longer face-to-face course, we would probably sit down and talk about these within the context of that tea-making process. But I will leave you to look at those at your own leisure and think about them in terms of the tea-making process and what they would actually mean. So these are questions. What is the product? Well, it's a cup of tea. Okay, but what kind of a cup of tea? Who's the customer? Is it a busy person on their way to work who wants a quick cup of tea in a plastic cup? Or is it a high society lady or gentleman who wants to sit and be served on the best bone china? What are the requirements? And that's also associated with the characteristics. Courtesy, timeliness, comfort. So based on that, what might the quality objectives be for the organization or the person who's making that cup of tea? What about the quality planning? How much detail needs to be in the procedure? Does it need to be documented or not? Maybe just a flow chart, or maybe just a very simple work instruction. What monitoring is needed? As I say, it would be, I think everybody would recognize, it would be crazy to say ISO 9001 requires process measurements, and therefore we're going to have a calibrated thermometer that we put into the kettle to make sure that the tea is, the water is at 100 degrees centigrade before we actually pour the tea into the cup. That would be overkill. We certainly don't need to do that because we can see when the water is boiling, because it starts to bubble and it starts to make a noise. So that relationship between the extent of the measurement and the monitoring that's needed. What about the effectiveness? Have we made a good cup of tea? Great. Yes, everybody's happy. They think, yeah, that's a very good cup of tea. The process is effective. But if we filled a 2-liter teapot with tea and made tea and we've only had one serving out of it, then we've not been very efficient. And regardless of the cost, we are wasting precious resources. We're wasting the energy made to boil the water, we're wasting tea, and we're wasting possibly our own time. So these are some of the factors, and this is how ISO 9000 brings all of this together and brings all these different concepts together. And then we couple that with Plan, Do, Check, Act. Plan in the simplest form, what to do, what's our objective, and how to do it using procedures, flow charts, work instructions, or whatever. Then we do what was planned, or at least we try to do what was planned. We may not always be successful. There may be resources lacking, or we may have some problems with the procedure. But constantly we should be checking, did things happen according to plan? Were there any problems? Even if there aren't any problems, we can then move to the act stage and say, how can we do it better next time? We can do it better next time by, of course, correcting things that went wrong, planning to avoid those things going wrong the next time, which is corrective action, and simply asking ourselves, is there a better way to do this? Which is the spirit of continual improvement, and it's very much a cultural kind of thing. So plan the process. Who's the customer? What are the requirements? What are the characteristics? What's the competence level for the people who will carry out the process? What are the risks involved? What's the likelihood of something going wrong? What would be the consequences if it did go wrong? Would they be a minor inconvenience? Or could it be a major disaster in a nuclear power plant, for example, or an airline? All of those things factor in to the amount of detail that we're going to put in to actually planning the process. What level of documentation is needed? What level of detail? And of course, that is related back to the competence level of the people who will actually be carrying out the process. How can the process be monitored? What measurements might be required? You know, maybe we are going to make some measurements in order to monitor the process. An example might be in a chemical plant where the process monitoring is done by making measurements of the temperature of the resin or the chemical product that's being made at various stages of the actual manufacturing process. Or it may be a measurement of the temperature at various stages, or pressure, or taste in the case of soft drink or beer manufacturers. At various stages in that manufacturing process, there are specialized people who will go along and taste the beer before it's pasteurized, or before it's sterilized, or before it's bottled, and so on. So all of these are things that need to be taken into consideration during the process planning stages. We then carry out the process by conducting those individual activities according to the planned sequence, following any procedures or work instructions if applicable, and excuse me, interacting with our colleagues, possibly in other departments or in other parts of the business. One of the beauties of the process approach is it helps us to break down those interdepartmental barriers. You know, those silos that sometimes one part of the organization doesn't talk to the other part. And the result of that is an inefficiency overall. You know, if I were to spend a little bit more time and energy and effort in my part of the process, I may simplify the next stage of the process tremendously for my colleague in another department. But if I'm very, very narrow-minded, I might say, oh no, that involves more work for me, and I'm not going to do that. Well, if the overall impact is that the process, the interfunctional process, becomes more efficient, then of course that is beneficial for the organization as a whole. So we need to understand the processes, and we need to understand how we work together so that we don't have overlap, we don't have repetition. You know, I'm doing something and then Shaukat is doing exactly the same thing because he doesn't realize that I've already done it. That's what we mean by the interactions within the different activities. We then check the process by monitoring the process parameters and the characteristics of the output, which is the product or service. We measure where necessary to determine conformity to requirements. So if we have, you know, an engineering component that has to be 10 millimeters in diameter plus or minus 0.1 millimeters so that it will fit into the assembly that we're about to make, we need to have those measurements, and we need to be able to demonstrate that the product is within the tolerance. And to do that, we need to have calibrated measuring equipment. We don't necessarily have to calibrate every single piece of measurement equipment in our business because ISO 9001 requires us to calibrate equipment that is used to demonstrate conformity of the product to requirements. So we may have kind of indicative measurements of temperature that we use during the process, but we don't need to exert the same level of rigor in those process measurements as we would do for the final process measurement with calibrated instruments. Now, for some processes, measurement on the process output might not be possible in a timely manner. An example would be, let's say we are in the poultry business and our product is fresh chicken. Well, I don't know how it is now. I spent quite some time many years ago helping a big Brazilian chicken producer to develop their quality management system. And at that time, of course, we don't want salmonella in the chicken. But the test for salmonella, the results used to take something like a week to come back because you had to grow the cultures and test the cultures and do the microbiological testing and so on. Well, after a week, the chicken's already been eaten, it's been cooked, people have for their dinners. At least for fresh chicken. For frozen chicken, the process may be different. And so frozen chicken for export, you can maybe have the luxury of waiting for the salmonella tests to come back. It may be compression tests on cured concrete. In the manufacturing industry, there are tests that are specified that say you make a small concrete block and you have to do the compression tests. You have to do those tests after 3 days, 7 days, and 28 days. Well, again, by 28 days, the concrete block is probably, or the pre-ready mixed concrete is probably already in the building. And so we have to have very strict controls on the process in order to be able to be confident that the output will meet the requirements. These traditionally we call special processes. It's not a huge big deal, it's nothing to be scared of, but typically these do need additional controls to provide confidence in their capability to generate conforming products. It may be by carrying out validation tests on a process. Welding in a construction is a very typical example of what is considered to be a special process. So if I get the welding procedure right on test blocks, and then I can destructively test those test blocks, and I say, yes, if I use these welding parameters, the process is capable of generating the necessary strength in the final block, then that is called validation of a special process, and I can have confidence that that will work. What I can't do, of course, is if I'm actually welding two pieces together, I can't then destructively test them because then I destroy the very piece of equipment that I'm wanting to make. So the amount of monitoring and measurement, again, will depend on the level of risk. In my process, I'm not going to monitor and measure every single parameter. I have to look at what's important for me as a business. I have to look at what is feasible. I have to look at the cost benefit and ultimately decide on the level of testing. Certainly these days, it's very rare to do 100% testing on every single product. We use things like statistical process control. We use things like sampling, lot approvals, and so on. And then finally, we are going to improve the process, which means improve performance by identifying any problems or non-conformities, correcting the problem. It may be by rework, by reworking the actual non-conforming product to bring it back into specification. Sometimes that's possible, sometimes it's not possible. I would say, let's say if I think in an agricultural situation, maybe we have a requirement for the cassava to be clean and well washed before we actually sell it to the market. Well, if it's not clean, we can rework it by putting it back into the cleaning plant and cleaning it some more. That is rework. That is correcting the problem. But it doesn't tell us, why did that problem happen? Was it because the process parameters in the cleaning plant weren't appropriate? Was it that we didn't clean it for long enough? Was it a human error or things like that? So we need to use systematic problem solving to identify the root cause and to take corrective actions to stop it from happening again. So there is that distinction between correcting the problem and taking corrective actions. We can feed back the results into subsequent planning of the process. We can maybe revise our work instructions. We can provide additional training to the people who maybe didn't understand the process or didn't do their job properly. That doesn't mean pointing the finger at them and blaming them. As managers, if we are managing our processes correctly, we have to ask the question, if somebody is not doing something properly, well, who hired that person? Who is responsible for training that person? Who is responsible for motivating that person? We are. And so it is a system problem. Let's not just point the finger at the person who may not be doing things right. And then finally, of course, identify areas for improvement. Is there a better way of doing this? Looking at trends. Are things overall stable? Are they getting worse? Are they getting better? Is somebody else within our organization or is a competitor actually doing better than we are? Can we learn from them? And also dealing with what we call in the total quality jargon, anomalies. Now, ISO 9000 doesn't talk about anomalies, but an anomaly is something that's different from what we expected. You know, maybe it's the cocoa beans that are a slightly different color. Well, the specification doesn't say that they have to be this particular color. But if we detect, hey, these beans are a different color from the last lot, it's something that we can investigate and say, why? Is it important? Does it affect the product quality without it necessarily being a non-conformity? So I hope this has given you a good amount of food for thought when we start talking about the process. And before we go on to the second part of this module, Shaukat and I have thought about some assignments for you to come up with within the context of University of Sierra Leone. So what we would ask you to do, working individually, is to choose one of the following topics. The process for delivering a lecture to undergraduate students, the process for developing, preparing a short course curriculum. It may be on quality management, it may be on Lean Six Sigma, it may be on anything that you choose, and the process for registering new students at the beginning of term. So we'd like you to choose one of those topics, and for your chosen topic, prepare a macro view of the process, like we did in the slide 18 of this slide pack. And then think about a more detailed process map, maybe aimed at somebody who hasn't conducted that process before, or who is a newcomer into the university and needs that information to be able to carry out their relevant roles. And then third, a more comprehensive process map showing the interactions with other relevant processes. And we've given you an example of that in slide 20. We would like to ask you to please work individually, but then to be prepared to present and discuss your assignment with colleagues to compare your approach. And this is a very, very healthy way of doing things, because you can then share the way that you've chosen to address the process. You can look at the good things and the bad things. You can combine your results and come up with a standard operating process for those particular things that you do in the department. So with that, let me pass back to Shorkat to draw this module to a conclusion. And we look forward to seeing you again for the second part, the continuation of this module. You need to unmute, Shorkat.
Thank you, Dr. Nigel. Uh, it was really a wonderful lecture. I am hopeful that USL would learn a lot about it. Definitely, as Dr. Nigel has explained, that the process and the process mapping is very important. If the process and the mapping is not there, you cannot apply the PDCA on that process, and then you cannot improve that process, because if the process is not there, improvement cannot be identified. So I am hopeful that assignment that Dr. Nigel has shared, that will impact a lot uh, in further understanding, and then you can learn a lot when you will prepare this assignment and would share this assignment. I will tell you in my email that what is the last date to share the assignment. I'm hopeful that Dr. Nigel will review each and every assignment, and then we will do interaction lecture with you. That will be somehow about question and answer session before we may start the module 2. So thank you very much, and we are hopeful that we will continue further
Thank you.
in the second module. Thank you, Dr. Nigel.